Hi there, I'm Roshan Kundar and I'm working as a software engineer in Ipinfusion. I'm going to talk about one of our product offering called ZebHA. ZebHA provides the high availability services for the ZebOS platform. High availability ensures a level of system resiliency that can provide continued service even in the event of component or module failure. In event of any failure, ZebHA would ensure that there is no interruption in the traffic forwarding. ZebHA would also recover the failed component either by switching to the backup node or recovering it on the same node. What is ZebHA? ZebHA is ZebOS with high availability. As you can see, ZebHA, it manages failure in 3 different stages: failure, transit, and recovery. So as you can see, a module of ZebOS went off. Then in that case, ZebHA would ensure that module goes down without any collateral damage. Collateral damage in the sense without any traffic outages or other dependent modules going down. Transit. In the case of transit, that means the module is not there at all, but still ZebHA would ensure that there is no traffic outage during when the module is down. Recovery. Now, ZebHA would recover the module, and in that case, ZebHA would ensure the module is recovered to the last stable state before the failure. So these are the 3 stages of failure that ZebHA would take care of. This is the high-level architecture of ZebHA. As you can see, there are ZebOS components like LACP, NSM, and XSTP, spanning tree protocol, for which high availability service needs to be provided. So there are few extra components added to ZebOS platform, and these components are AMF, CAL, and checkpoint services. These are the backbone of ZebHA services. AMF, that is Availability Management Framework, would monitor the ZebOS processes, and in event of any failure, it would decide upon the recovery policy for these components. CAL is attached to each and every ZebOS process. The job of CAL is to convert the protocol specific data into a blob of memory and checkpoint it and pass it on to the checkpoint services, which will later get checkpointed into the main memory, and vice versa. Like during the recovery, the blob of memory would be retrieved by the checkpoint services and it would be passed on to the CAL. Now CAL will convert that memory into protocol specific data from which the state could be recovered. Checkpoint services is one of the key component of ZebHA platform. Checkpoint services would take the information from the CAL and store it in the main memory. In case of simplex node, it would store it on the local node, while in case of 2N mode, this particular information would be replicated to the standby node as well. So this is the overview of ZebHA, architectural overview of ZebHA. ZebHA is integrated with OpenSAF. As I said before, it supports the common services such as checkpoint services, AMF, etc. Integration with AMF allows the system to be monitored and recovered, and recovery action to be defined. ZebHA supports both simplex mode of operation as well as 2N redundancy. We'll go into the details of these mode of operations in subsequent slides. As I mentioned before, CAL is integrated part of ZebHA. It interacts with OpenSAF checkpoint services to save and recover the ZebHA processes. Protocol defined graceful restart feature can be integrated with ZebHA to build a highly redundant system. Graceful restart is a feature provided by a protocol. It would only protect against the failure of the protocol. But with ZebHA, we could also provide a graceful restart and non-stop forwarding if any key components like RIP or interface manager like NSM has failed. Another way to recover faster from failure is by enabling stateful switchover. This feature is supported for few modules in ZebHA. AMF. Availability Management Framework is another key component of ZebHA platform. It provides a service availability by coordinating with redundant resources in case of 2N mode of operation to deliver a system with no single point of failure. AMF also monitors the health of the component and it decides upon what should be the recovery policy in case of failure. Like in case of simplex, restarting this failed module on the same node, while in 2N it would be switching to the backup node. In case of 2N, AMF is responsible for assigning the states like active and standby to the redundant resources. Checkpoint services. This is another key component of ZebHA. ZebHA CAL framework provides an interface to ZebOS protocol modules to checkpoint protocol specific data. CAL framework would convert the protocol specific data into a blob of memory which would be checkpointed into the main memory by OpenStack checkpoint services. Also, while recovering, it will convert this blob of memory which it gets from the OpenStack checkpoint services into protocol specific data, and the failed process would reconstruct its previous state using this particular data. Checkpoint services allows ZebHA to save its state so that in case of failure the process could be restored from the last checkpoint data. Since the ZebHA operates in two modes like simplex or 2N mode. In simplex mode, the checkpoint data is stored only in the local node, while in 2N mode the checkpoints data is stored in the local node as well as it is replicated on the standby node if ZebHA is running on the standby node. In 2N mode, the standby would operate as hot standby. In 2N mode of operation, the standby would operate as hot standby. Any change in active would be replicated on the standby as well. So both active and standby would be in perfect sync with each other if ZebHA is running on both active and standby. Any process change in the active node would be immediately replicated on the standby. So in case of any failure on the active node, standby would take over from where active has left. Flavors of ZebHA. ZebHA achieves high availability in the following ways: stateful switchover and graceful restart with SSO. We'll go into the details of these types of high availability that ZebHA offers in bit of more detail. Stateful switchover. As and when the module transitions from different state, the data pertaining to that state is checkpointed. Now, if ZebHA is running in the simplex mode of operation, that data is checkpointed into the local node. If it is working in the 2N mode of operation, that particular data which is checkpointed would get replicated to the standby node as well. When the failure occurs, the process is restarted and the checkpoint data is used to restore the process to the last checkpointed state. So the beauty of SSO is it doesn't require any help from the neighbor to recover. As compared to graceful restart would coordinate after the process comes up. The graceful restart would coordinate with its neighbor to get some information so that it could recover to the previous state. But in case of stateful switchover, all the state information pertaining to that particular module would be checkpointed. So it doesn't require any help from the neighbor to regain its previous state. Neighbor won't even come to know that there was a failure on the peer module and it came. If it is a simplex mode of operation, the process would recover from the same node. If it is not, then if it is a 2N mode of operation, it would switch over to the standby mode. So this is a small sample of how the simplex mode works. So you have an AMF which monitors. I've taken example of MSTP. Also you have a checkpoint database where the information pertaining to the MSTP would be stored. So this is the snapshot before the failure. MSTP is running. AMF is monitoring MSTP. It has initialized the CDB section. So there has been state changes in MSTP and the checkpoint has been written onto the checkpoint database. Now there's a failure, MSTP goes off, AMF would restart, AMF would come to know that MSTP has gone down, there has been failure on MSTP. AMF would restart the MSTP process it would read from the checkpoint database. It would recreate ZebHA would recreate the MSTP state before the failure, and MSTP is up and running again. This is the 2N mode of operation, where MSTP is running on both active node as well as standby node. AMF is monitoring MSTP. AMF is also running on both the nodes. Now, any state change in MSTP would be returned on to the active node checkpoint database. This would be replicated onto the standby node checkpoint database, and standby node would read it and create a state which is in sync with the active node. So this is acting as a hot standby now. So any failure on the active node, standby would take over and become active, while on the failed node, AMF would restart the MSTP process and it would act as a standby node. So the standby became new active and the old active became new standby. Then any change on the MSTP on the new active would be written onto the checkpoint database, and this would be replicated to the new standby now. Graceful restart with SSO. This would be useful in multiple node failures, multiple module failures, also node failure. In this case, the key module, if there is any failure in the key modules like NSM or RIP, which by default has SSO support in ZebHA platform. So in this case, say OSPF goes down along with the RIP. RIP would be recovered using SSO, while OSPF would come up using graceful restart. GR capable module would recover using graceful restart, while the modules like NSM RIP would recover using SSO. So this is a small. Now consider a case where OSPF GR and RIPD. So RIPD, the state changes in RIPD is getting checkpointed continuously into the CDB. Both OSPF as well as RIPD went off. RIPD would be recovered using the stateful switchover, which is by default supported in ZebHA. So it will read from the checkpoint database. RIPD is completely recovered. Now OSPF would come up using graceful restart protocol. So in this, with graceful restart with SSO, in this particular scenario, there won't be any traffic outages. So we'll achieve non-stop forwarding even if the key components are failed. ZebHA deployment scenario. So this is whatever we have seen in the previous slides. This is kind of a summarization of all those slides. So in this case, we'll be having LACP, NSM, STP, all of them interacting with fault management AMF, that is availability management framework, which in case of 2N, it will talk to the standby AMF. Also, all these modules would interact with checkpoint services, which if 2N is there, it would get replicated onto the standby module as well. Thus, ZebHA would help you achieve a pre-agreed level of system uptime for your network equipment. It would help you protect your network equipment from the traffic outage during the software or system failure. Also, it would reduce the convergence time after the system recovery.